Now I will discuss some Java features related to object-oriented programming and the techniques which are used quite a lot in the Android platform. So here I have an IntelliJ IDEA console application, so I can demonstrate some of the language features more quickly than I do it in Android Studio, because any time you run a thing in Android Studio, it takes some time, and obviously some things are a bit harder to see in mobile apps than you can just print out things in the console. So let me replicate the example from the webinar. So I'll add a model class, a new model class here. So I'll create a nested package model and then class bank client. So bank client normally has something like name. Bank client certainly has a number of accounts, but for this simple purpose, I will simply add the balance variable on the bank client class, even though again in reality this will have a one-to-many relationship, and then the balance is certainly a property of the bank account rather than the bank client in general. But let's assume this kind of a summarized balance, and I'll have a method to withdraw some money from the client's account, which will obviously result in this subtraction with some potential checks that the balance is high enough with the allowed credit and all these different policies that a bank may impose. It's not that important for the purpose of the demonstration. Now, let's assume that this happens in the so-called online banking, and this results in some sort of email sent to a client, or an SMS message, more real thing, an SMS being sent to a client. So the question is, where can we put the logic of sending an SMS? Well, one would say, why don't we just put it right here? So why don't declare a method called send SMS with a certain message? And so here we have all the logic for kind of communicating with a possible SMS online server. Maybe there is some local modem that can send SMSs. It doesn't matter. So here we'll say all the corresponding logic that allows us to send a single SMS for this content. So for simple purpose, I will just put a console print here. So I will prefix it with email plus message. All right, so having this method here, we can call it right from the class. They are in the single class. We can make it private if we don't want it to be used outside of the bank client class anyway. So let's say that have a certain number withdrawn. Format, and then we'll put in delta and balance. So let's instantiate a new client. Again, we can potentially make a constructor here. Let's add both constructors, add parameters in for the both fields. And from the main program, let me instantiate a new bank client. Name John Smith, and with the initial balance of 1,000 something, 1,000 euros. And let's assume this to be euros. Now it's a client withdraw. Yeah, the only thing that obviously names in Java, they should start with a low letter. It's the convention. Let's withdraw 100 euros. So this should result in an SMS being sent to a client. We'll see it as a console message. So let's run this. And well, okay, I think I have the wrong specifier here. I think it should be /d. Sorry, %d. Once again, let's go to main. Let's run it. Yeah. So now I have this message being sent by well, saying by email. Obviously, this is an SMS message that we agreed on. Okay, they're just some minor fixes. Anyway, the main idea here is that the code for sending SMSs resides in the bank line class. Now, one of the key principles of good object-oriented design is that we split responsibilities evenly between classes. And there is even a certain principle named a single responsibility principle that tells us that each class should have really only one responsibility. Now, if we look at the class, and its name, it's called bank client, it says something that really this class should only contain logic related to, well, a person having accounts inside a bank. So obviously this logic that a client has a name, obviously some balance, it's all correct. And this logic that we subtract something from a current balance, that's about the bank client class. Now if you look at this method send SMS, this has nothing to do with bank client because SMS can be sent for all other different purposes. So really what we should have is that we should have a separate class, let's call it SMS client, that will allow us to send SMSs. So it will have something like send SMS. Or I can simply copy this from the current bank client class. I'll copy it to SMS client, and so this I will have as a method extracted to new class. So obviously now I cannot call this method from bank client like this because obviously I don't have the reference to the SMS. Well, what I can do is I can say SMS client equals new SMS client, and then client send SMS. Well, that could do. That will still result in exactly the same result of the program. Still SMS being sent, but now the logic for the SMS sending itself, the core process, underlying process, resides in a different class. The thing that we still have to solve is to move this instantiation somewhere else. Because now, basically, each client, as soon as we make a withdraw operation, instantiates an SMS client here. Well, what we could have done is we could have extracted the SMS client here at the top, so we could instantiate, let's say, here inside the bank client constructor, but still it wouldn't solve the issue that really the bank client, again, itself should not really be responsible for instantiating the class. Well, if we understand that a class should not be responsible for instantiating an external dependency, we can call SMS client as external dependency, then one way to go is to simply pass this as a constructor parameter or declare a special method like set SMS client. So then we can pass this dependency from outside. But let's do it through a constructor. So if I do the dependency injection, and let's save it at the class level. So we'll do the obvious assignment. Now no need to instantiate it here, so we'll simply call the already provided client from somewhere outside. So again, one way forward. Obviously now when we instantiate a client, we also need to instantiate the bank client. We also have to instantiate the SMS gateway or whatever we may call it with all the logic, and then we pass it as the last parameter. Again, doesn't change any logic, still the same message printed out, but we are kind of refactoring the project to a better design. That's what we very often do. But then finally, the last drawback that we have currently in our bank client implementation is that what if really this SMS client will change in the future? In the sense that what if we need some other way of notifying a client, not by SMS, maybe by email, maybe by WhatsApp, Telegram, Viber, whatever other messaging services exist today. So really this is a kind of strong dependency because we're referencing a concrete class. So that's where interfaces come as a solution. So instead of referencing a class with its logic here, obviously again here it would have not system out print line, but it would have some complicated logic for issuing as SMS send command. So we declare an interface on top of it. So create a Java class, but now I will change it to interface. Let's name it notification channel. And this contains just a general description of a method that should be supported by all different clients, SMS, email, WhatsApp, whatever we may think of. So let's just name a message, this method send message. with a certain content. But notice the interface does not provide any implementation. That's the whole purpose of the interface. The interface is there to specify methods and how they should look like. But as soon as we have the interface, we can now reference this interface. Notice the different icon here. We can reference it inside the classes. We can say that this class, it implements our notification channel interface. Notice that this is now an error because the interface requires a method called send message, whereas my client has a method called send SMS. So we'll replace the name by a more general one, send message. And now this fully conforms with interface specification, even though the parameter name is named differently. It doesn't have this is all right with the Java language. Parameters can be named differently inside the interface and inside the class implementing it. The important part is that the method signature directly corresponds with the interface signature. If, for example, we added some additional parameter here, then again this would be no longer a valid interface implementation because this method does not match by signature the one declared inside the interface. So we have to exactly match here. Now we're able to declare additional clients. So we can say that new Java class. We can even put it inside a different package, notification, let's say email client. That would create a nested notification package name. I can even move my SMS client here. So notice that the package should change. I can actually put the interface there as well with refactoring all the things. So now I have an email client. Again, I say it implements the notification channel interface. Alt-Enter, implement methods. So here I'm putting out that this will be sent by email. Now this makes a very significant difference. Not so far yet, because again, my bank client is still referencing the interface. One thing which I probably don't like at the current moment is that, well, apart from the different name of the method that I should call, the notification is really not part of the model. The model is about declaring class with some properties, so I extract notification to the general package level. Hopefully it should rename all the namespaces, all the package names appropriately. So now instead of referencing the concrete class called SMS client inside my bank client class, I would just reference something which is an interface. So here I'm providing the notification channel. I can even again refactor this, call it channel. And here as well. So now we're withdrawing some money and then sending a notification through some abstract channel. So this now, in this design now, the bank client does not really know what this external component will be, what kind of logic it will implement. It will just provide it as an external dependency, and our bank client class simply uses what it is provided with. And now we have the great improvement. Now we can say that we have an SMS client, we have an email client, and we can actually easily interchange the notification channel for a bank client. For instance, at the moment, this client is being notified by SMSs. Now we can easily change it to email. Notice that I'm not changing anything inside the bank client, and I rerun the program, and now the notifications are sent through an email instead of SMS. I simply send it right here, SMS, and now this changes to SMS. Certainly, what I could have also done is instead of providing one single notification channel, I just mentioned this opportunity. I can, for example, provide an array list of interfaces, array list of notification channels. So I'll save it as many notification channels. And then, for instance, I could do a for loop here, and I can use any of the notification channels that are available there, or all the active ones. For example, what I could have done is I could have added something like is active. So I can activate and deactivate each of the communication channels that I have. So at some stage, one becomes active, another one becomes inactive, and obviously I can kind of add the set active methods here as well. So I could do all the different things to achieve the logic. The important thing that I'm solving right now is that I'm making my bank line class really independent of this external dependency that I'm providing as a parameter inside the constructor. So that's, by the way, the technique which is called dependency injection. We're injecting an external notification channel dependency through the class constructor. There are other possibilities of how we can do this. For example, we can declare a method called like add notification channel, and then provide something implementing this interface. That's, again, one way to do it. But the most common one is introducing independence through a constructor, even though, again, other possibilities exist. So the one last thing that I will mention here, and it will now really correlate with what we've seen inside Android, is that Java allows you to create the so-called anonymous classes when a method expects an object implementing a certain interface, an object of a class implementing an interface. And again, there is no possibility to instantiate just the notification channel interface. There is no way to do it. Interfaces cannot be instantiated. So when some interface is expected, we should always provide a class implementing it. However, what we could do is we could kind of start writing a new notification channel, and this would construct the so-called anonymous class. The word anonymous means that this class has no name, like our other two classes, which have their distinct names, SMS client and email client. But still, again, this can do all of the normal things the other classes do. Let's say, for example, this is a WhatsApp notification channel. So now again, we'll replace the channel, even though some latest Java versions allow you to replace this with so-called lambda expressions, but let's just stick with the old Java way to define the synonymous methods. So now this notification is sent through WhatsApp instead of SMS and email. And that's exactly the thing which you see in Android. When we see the onClick listener is in fact an interface, and the interface is implemented in the anonymous class, which we define kind of inline in the method in the assignment of the onClick handler. That's what we do in some of the ways of assigning a button click handler in Android. So this concludes this video on explaining the object-oriented features and how they are implemented in Java. Next, we'll move back to Android and take a look at how the network interconnection can be implemented.